tackle about the series notation. For example,
summation of k goes to k is equal to 0 to 2. Take note, 0 is our starting number and 2 is our ending number. So this will become 0 plus 1 plus 2. 0 plus 1 plus 2 is equal to 3. So 3 is the sum of our series. Next examination of 2k plus 3 goes to k is equal to 2 to 5. So it will become 2 times 2 plus 3 plus 2 times 3 plus 3 plus 2 times 4 plus 3 plus 2 times 5 plus 3. Now, let's simplify. 2 times 2 plus 3 is equal to 7. 2 times 3 plus 3 is equal to 9. 2 times 4 plus 3 is 11. 2 times 5 plus 3 is 13. 7 plus 9 plus 11 plus 13 is equal to 40. So, the sum of our series is 40.
Good afternoon everyone. My name is Adrian Gomez. I'm going to solve the trigonometric function of a given angle. So the given angle is 2 pi over 3. So the 2 pi over 3 is belong to the second quadrant. So this is the 2 pi over 3. And the 2 pi over 3, the order is negative 1, negative 1 half over 2. So x and y, sine, cosine. So the sine value is equal to negative 1, negative 1 over 2. Negative 1 over 2, then the cosine value is the square root of 3 over 2. The sine, the cosecant is equal to the reverse of the sine. Cosecant is 2, negative 1 equals to negative 2. So the cosecant is negative 2. And the secant is 2 square root of 3. 2 over square root of 3. Then the tangent is y over x. So the tangent is square root of 3 over 2 over negative 1 half. Then the rule of this is we're going to multiply then times 2 to negative 1. So then there is a babaw to negative 1. So cancel equals to square root of 3 over 1 is equals to square root of 3. The tangent is the square root of 3. So the cotangent is equal to x over 1. So negative 1 half over square root of 3 over 2. So going to 2 over square root of 3 then times 2 square root of 3. So cancel out, and cancel out is equals to negative 1 square root of 3. Then we're going to the process of rationalize. So square root of 3 or square root of 3 is equal to negative 1 square root of 3 over 3. So the cotangent is equal to negative 1 square root of 3 over 3. Going to proceed example number 2. Given the 11 pi over 6. So in the unit circle, the 11 pi over 6 is belong here, in the quadrant 4. In here, coordinate is equal to square root of 3 over 2 and negative 1 over 2. So the x is equals to the sine. So sine is equals to square root of 3 over 2. Then the cosine is equal to negative 1 over 2. Then the cosecant is the reverse of sine is equals to 2 square root of 3. Then we're going to rationalize square root of 3. Square root of 3 is equals to 2 square root of 3 over 3. The cosecant is equals to 2 square root of 3 over 3. Then the secant is the reverse of the cosine. So 2 negative 1 is equals to negative 2. The secant is negative 2. The tangent is equals to y over x. So negative 1 half over square root of 3 over 2. Then going to on this the rules. Close square root of 3. Yeah, close square root of 3 is equals to cancel is equals to negative 1 square root of 3. Going to 1. Rationalize. So square root of 3 or square root of 3 is equals to 1 square root of 3 over 3. So the tangent is 1 square root of 3 over 3. Then the cotangent is x over y. Square root of 3 over 2. Then over negative 1 up. So 2 negative 1 to negative 1. So cancel out 2 and 2. Then the remaining is square root of 3 over negative 1. So the cotangent is equals to square root of 3 negative 1. So that's all. Thank you.
Hello, my name is Jadis Lane Reyes, and I am here to show you how to solve trigonometric functions given a point on the terminal side, provided with 2 examples. Let's begin. Trigonometric functions given a point on the terminal side. Example number 1, negative 8 and negative 5. As you can see, these are coordinates that can be inputted in the Cartesian plane. Now what we need to find is the reference angle, the opposite and adjacent side, as well as the hypotenuse, and the 6 trigonometric function. Let us now graph our x and y coordinates into our Cartesian plane. We would then create a right triangle using the given points and the reference angle. The reference angle is the angle that the terminal angle makes with the x-axis. And since the measurement of the angle is unknown, we shall denote it with theta. And now we are going to label the sides of the right triangle with its corresponding lengths, except for the hypotenuse, which is still missing and we need to solve for it. And now that we have our reference angle, we can now find the different sides of our right triangle. Now moving on to the hypotenuse and how to solve it. This is the Pythagorean theorem, a squared plus b squared is equals to c squared. And translating it into simpler terms, it's legs squared plus another leg squared is equals to hypotenuse squared. Now on to the substitution. Hypotenuse squared is equals to 5 squared plus 8 squared, and that is equals to hypotenuse squared equals 25 plus 64, which equals to 89. And since the hypotenuse is squared, the final answer is square root of 89, since it cannot be simplified further. And now that we have found all the measurements of our right triangle sides, we shall now move on to finding the 6 trigonometric functions, starting with our sine theta, which is equals to opposite over hypotenuse. Our sine theta should be equals to 5 over the square root of 89, but we need to rationalize the radicals. In rationalizing radicals, what you need to do is multiply the numerator and denominator by a radical that will get rid of the radical in the denominator. In this case, it is the square root of 89. So we need to multiply that to 5 over square root of 89, and that is equals to 5 square root of 89 over 89, because the square root will be cancelled. Now moving on to our cosine theta, which is equals to adjacent over hypotenuse. Now, as like the first one, which is sine theta, it is equals to the adjacent side, which is 8, over the hypotenuse, which is square root of 89. We would then multiply it to square root of 89 over square root of 89, so that we can factor it out. And that will equals to 8 square root of 89 over 89. Now with our tangent theta, which is equals to opposite over adjacent, and that is just 5 over 8. Now with the cosecant theta, it is just hypotenuse over opposite, which is the opposite of the sine theta, actually. So, square root of 89 over 5. And we don't need to rationalize it because it is correct and cannot be simplified. And also with our secant theta, which is hypotenuse over adjacent, it is equals to square root of 89 over adjacent, which is 8. Now with the cotangent theta, which is just the opposite of tangent theta, which is adjacent over opposite, and that is 8 over 5. Now going back to our graph, as you can see, our coordinates is exactly in the third quadrant, and there is corresponding signs to different quadrants. And in this case, tangent and cotangent are the only ones that should be positive. So which means it's negative sine, negative cosine, negative cosecant, negative second, but positive cotangent and tangent. And this is how you solve all the 6 trigonometric functions and also different sides of the right triangle given by a point on the terminal side.
Now, on to the example number 2. We have 6 and 7 as our x and y coordinates, and we shall graph them into our Cartesian plane. We now have our right triangle and also our reference angle, and with that we should now determine the measurements of the 2 sides and solve for the hypotenuse, since we do not know what its measurement is. Also, take note that our right triangle is located on the first quadrant, and we shall need the information later on. For now, we shall input now the different measurements based on our theta, our reference angle, and what's its opposite side and adjacent side. Now let us solve for our hypotenuse. Just like the first example, we will always use the Pythagorean theorem with solving and finding our hypotenuse. The formula will always be a squared plus b squared equals c squared, or in other terms, hypotenuse squared is equals to leg squared plus another leg squared. And in solving this, we have the answer of square root of 85. Now, let us solve for our 6 trigonometric functions. First with our sine theta, which is opposite over hypotenuse, and that would be 7 over square root of 85. And we need to rationalize the radicals again, and that would lead to 7 over square root of 85 times square root of 85 over square root of 85, and that would equals to 7 square root of 85 over 85. Cosine theta with adjacent over hypotenuse, that would be 6 over square root of 85 times square root of 85 over square root of 85, and that would equals to 6 square root of 85 over 85. With tangent theta, it is opposite over adjacent, which means opposite side, which is 7, over adjacent side, which is 6. Now, moving on to our cosecant theta, which is hypotenuse over opposite. That would be square root of 85 over 7. And with our secant theta, that would be hypotenuse over adjacent, which is square root of 85 over 6. And lastly, with our cotangent theta, that is adjacent over opposite, which is 6 over 7. Now going back to our corresponding quadrant, which is quadrant 1, according to the rules of sines in trigonometric functions, all are positive when the given point is on the first quadrant. So that means that all our answers are supposed to be positive. And that's pretty much it. Thank you for listening.